presentation. I wanted to show you how some of these foams are made. They're made in either rolls, continuous rolls, your company or you guys like to call them extrusions. Buns or blocks are in the middle, and they're typically thicker and have a final cell structure, and then sometimes they can be made in profiles or shapes. And again, all of this is rubber and plastic. A lot of my presentation and my samples are all about rubber, but the same holds true for plastic also. And one way to see how a product is made, so Arlen, there you are at your customer's thing. I can switch to Brandon if you want. Oh, I think we lost him already. See, this is what I'm saying. If somebody gives example, so the continuous rolls are made in long 300-foot ovens, and they're made in the standard atmospheric pressure. So they're just made in the factory right behind that door, actually. Buns are made in a hydraulic press under high pressure, and that makes a difference because the cell structure now makes a difference. Okay, so you can actually see from here, from where you're all sitting, that the left side of these samples are fine cell structure. You can't see the cells. And on the right side, you can actually see the cells. Okay, so I'll pass two of them around, and you know immediately that how it's made just by looking at the sample. These are both closed cell, but one is made in a press with a fine cell structure. One is made in a roll, in a continuous roll under standard atmospheric pressure. So what we're trying to do at the end of the day is to figure out which foam is best. Well, number one, identify the foam, identify the application, but which foam is best for the application. And it starts with how the foam is made. And cell structure is your key indicator. All right, so we've got three kinds of cell structures: a closed cell, which obviously doesn't allow water to go through; open cell, which is an example would be a sponge, where the water goes in and out and in and out; and semi-closed are mechanically crushed, softer foams that are actually broken to make them soft. And they're broken using one of a very large one of these things, metal rollers that actually puncture the cells. Okay, so there's some advantages for closed cell and open cell. The biggest one for closed cell is water absorption, certainly buoyancy, flotation, and on the right side is water absorption. So you want the water to go through, then you would want an open cell foam. So now we've got cell structure and polymer to differentiate some of these foams. Okay, so continuous rolls are made in a 300-foot oven, so the material gets mixed. This is a rubber plant here. Get mixed basically on the second floor, drops down into some mills, and then goes to the extruder. The middle picture is raw stock going into the oven. So the raw stock has to be certain thickness and certain width. It's pretty thin. And then it goes 300 feet into this oven where it gets cured and expanded. At the end, on the left side, it comes out already expanded now into like 4 or 5 foot widths and maybe an inch and a quarter, an inch and a half. And then it starts getting cooled, all still continuous rolls, not cut. And then they get trimmed, the edges get trimmed, and then they get packaged into like 100-foot rolls or 50-foot rolls or 200-foot rolls, depending on the thickness of the foam. So that's the continuous roll sheet manufacturing process. Buns and blocks are kind of similar at the beginning. Again, second floor, it gets mixed in a special rubber mixer, drops down into some mills, and then gets extruded, calendared, which is just to make the raw stock, again, a certain size, dimension, and thickness. And with buns or blocks, you have to make these rectangles. There's like 4 or 5 plies or 3 or 4 plies of squares on the cutting table, all separated by wax paper so they don't stick. And now you move those plies, each one of those little bundles, into the press, 6-gang press. That's a hydraulic press there, high hydraulic pressure. Steam is all over the inside of the press, so there's heat. And a certain time later, it kind of pops out of there, and then they move it into an oven to do the final expansion. So you've seen buns out here in polyethylene foam, right? And if you've seen a bun out, you know two things. Well, of course, you know it's polyethylene because it says so on the label. But if it's a bun, you know it's a fine cell structure. Okay, now we're going back to cell structure. And these things have a skin on the outside too. And so for rubber, all of the expansion gets expanded in the oven. Looks like a twin size mattress, which was right there, a list of finished buns. For some of the cross-linked bun products, they're a little chunk of the raw stock. I think they call it a billet. And so it's mixed, off the screen there. And then again, it looks the same as the rubber process making plastic. You've got a gang of 6 presses there, or 6 levels, 6 molds. Shove it in, close it up, high hydraulic pressure, steam all over the machine, and it pops out making, and then there's a jacket there. We have a question. Okay. And anyone can ask a question anytime, okay? So the cross-link buns, the plastic buns, are then expanded in the jacket, and then there's some cleaning going on, and this is what a cross-link bun looks like, which you guys all know because you're actually the experts.